Okay, good morning again, class. Ang ano natin ngayon ay topic natin would be oximetry. Oximetry. Okay, last time ang pinag-usapan natin paano tayo magme-measure, di ba? Measurement analysis. Tapos ang lagi natin basihan doon ay meron tayong gold standard. Meron tayong pinagbabasihan na other device para makapag-proceed sa ano natin. Makapag-proceed doon sa measurement natin. However, kung kunyari magtatrabaho kayo sa isang kumpanya na magde-develop ng isang biomedical device, then you would be tasked to develop or conceptualize kung paano mo gagawin yung device without without the help of other devices. So gagawin mo yung measurement mo from the very start of the device. Wala kang pagbabasihan. Kunyari kayo una magde-develop ng device. So kailangan mo maalala niyo yung mga physical equations niyo to guide you. So for this topic, ang itatalakayin natin would be oximetry. Okay? Ang oximetry ay yung measurement ng dugo ng oxygenation ng dugo. Okay? So kunyari, develop kayo ng oximeters and you don't want it to base on other devices, then you would need your equations here. Okay, wait lang. Okay. Sige. Okay, kung sino sa inyo nakatry ng pulse oximeters, they would output something like this, SpO2. Okay? And this means that ito yung saturation. Yung meaning niyan of peripheral oxygen. Okay? So SpO2 means saturation of peripheral oxygen. Now for oximetry, ang gamit natin, usual na gamit natin would be optical sensors. So you would bombard your blood. Bombard blood with light. Then titingnan mo kung ilan yung mababawas dun na light, ma-absorb nung blood. Okay. Tapos para makuha yung amount of oxygenation. So syempre yung SpO2 natin nakatutok. SpO2 natin would be defined as something like this. Defined as yung concentration na oxygenated hemoglobin. So Hb yung hemoglobin, tapos O2 yung oxygen. Then the total, which is yung, and those hemoglobin that are not carrying oxygen. Okay, so meron tayong ganitong equation. So percentage lang ito ng oxygenated with respect to the total. Okay? Okay. So sabi ko nga, ang gamit natin dito ay optical sensor, optical yung means natin. So with that, we can actually use Beer-Lambert's law. Beer-Lambert's law, which states that yung intensity ng light, measured intensity, baguhin natin color para fit. Intensity ay equal sa initial intensity tapos yung dadaanan niya. So yung dadaanan niya would reduce the factor by an exponential factor, which is somewhat can be defined as this. So alpha would be yung absorption coefficient. So ito yung absorption coefficient would tell you kung gaano ka kung paano ina-absorb ng material yung light na binibigay mo. Okay? So with different light, iba yung absorption coefficient ng material. Okay? Diba kasi ganun yung quantum mechanics. May mga prefer na ilaw yung ibang materials. Okay? D would be distance. Path length to. No? So yung dinaanan mo, syempre, would matter. Actually, dapat C pala una. Yung CI concentration. Concentration ng material. Okay. Right. Concentration. Okay. So yung C concentration ng material, tapos i-multiply mo yun sa D para makuha yung total amount ng material in that region. Tapos multiply mo with alpha para makuha yung total yung total absorption niya, yung power na absorption niya. So you have that factor. Okay? You have that factor. Now, syempre i-bombard nga natin yung ilaw sa dugo. So yung yung mga dadaanan niya, kunyari nagbato tayo ng red light, for red. Okay, so red would be dito. Let's say that yung intensity ng light for red is defined as I sub r, and then yung incident ng light na yon will be named as I naught r. Okay? And then lalagay na natin yung exponential factor which can be written as something like this. N is equal to 1 alpha n c. Okay, so huwag kayo malula, no? Tamad lang ako mag-expand ng tawag dito, ng mga variables. Nakapagod magsulat. Okay, anyway, so bakit tatlo yung terms na dapat na nandito? So pwede nating pagsamasamahin yung mga bagay, no? So yung una, 'di ba, meron tayong tatlong terms dito. Yung una would be yung sa oxygenated na hemoglobin, tapos yung isa hemoglobin, tapos yung isa everything else. Okay? Okay, so let's write that down. So alpha 1 would be the absorption coefficient for tissues plus everything else. Huwag natin gamitin yung equal sign. Tissues plus everything else. Alpha 2 would be the hemoglobin, concentration of hemoglobin. Alpha 3 would be concentration of the concentration for the absorption coefficient of these guys. Okay. And then consequently, we have C1 for concentration for tissues and everything else. C2 would be for hemoglobin, and C3 for oxygenated hemoglobin. Okay? Okay. Now, tinry mo ngayon ikabit yung prototype ng sensor mo na nakaka-measure ng intensities. And napansin mo that the actual thing that's happening looks like this. Something like this. Okay? Mapansin mo na measure mo rin talaga yung heartbeat. Okay, and then from this graph na nakuha mo, it would imply that yung lower portion could actually be attributed. So itong mga nandito sa baba could be attributed doon sa tissues and everything else. Okay. Okay. And then pansin mo itong part na to would be from the incoming rush of blood, tapos yung pag-drain ng blood. So yung heartbeat essentially. Okay? Okay. Now let's rewrite our equation. Sa equation kasi nating una, kung bakit ko dinedefine itong mga bagay na to, is that ganito yung makukuha natin. D alpha 1 C1 minus D alpha 2 C2. So ito expanded form nung kanina, summation D alpha 3 C2. Okay? Okay, now pansinin niyo, yung D, yung path length ay pare-pareha. Syempre, ito yung lapad ng fingers. Okay, syempre hindi mo bago yung lapad ng fingers as you measure, di ba? So lahat yung dadaanan niya. Tapos, okay, may concentration amount of tissues na ganito, hemoglobin, and then the oxygenated hemoglobin. Now, of course, you can proceed with this, no? Pero hassle yung may extra factor ka na irrelevant sa measurement mo. So in tissues, hindi na wala tayong paki dito. So let's try to find a way to eliminate this. Okay? And napansin na nga natin na mayroong heartbeat. So with this, we can actually have something like IR max tsaka IR min. Okay? So syempre may maximum intensity ka, which is this part. Tapos minimum would be itong part na lang na to. Okay? Max, min, max, min. So yung IR max mo would still look like this. Syempre yung incident, di magbabago yan. Di magbabago yung incident light mo. Tapos would look like this. And then okay, bakit may D2? So yung D2 ngayon i-define natin as yung expansion nung vessel sa loob. Okay, so yung D2 would be defined as yung expanded length width nung vessels sa dugo. So pag pumasok yung dugo, syempre mag-expand yung vessels. But not the tissues, syempre. Yung buong daliri hindi magbabago. So ito pa rin yung yung sa tissues and everything else. Dito lang sa factors na nandito would be yung sa rush of blood. Okay, sa rush of blood. And then sa pag-drain ng blood, similarly, we could have something like this. Siyempre, hindi magbabago yung daliri. No? Ganun pa rin siya kalaki. And then, okay? Okay. Now, from these two, pwede natin kuhanin yung ratio nung max tsaka min. Okay. Para matanggal natin yung mga irrelevant matters in hand. So the ratio ay R max ay R min. I-divide natin to. So magka-cancel yung I not R. Tapos magdi-divide tong dalawang exponential and consequently magma-minus lang yung mga exponents nila. So itong unang factor natin or terms, kung gusto niyo terms, magka-cancel lang to. For the tissues and everything else. So matitira would be alpha 2 C2 tapos D2 minus D1. And then for the oxygenated hemoglobin, similarly, we have okay. So we now have IR max over IR min given by this exponential term. Okay? Now, hindi naman natin ngayon alam yung irrelevant naman ngayon dito yung D2 and D1 or hindi natin ma-measure directly, di ba? Kasi ito yung expansion ng vessels. So it would be nice to have another reference light. So magagamit ka pa ng isang beam of light. So gagamit naman tayo ng infrared. So ganito usually yung paggawa ng oximeters. So, dalawang ilaw. Infrared naman yung next na light. So in a similar way, we can produce the equations IR max over hindi ko na gagawin. So we follow the similar way of doing this. So we would actually obtain something like this. And then okay. Ano tong alpha 5 tsaka alpha 6? Yung alpha 6 would be, yung alpha 5 would be defined as yung sa absorption ng hemoglobin with respect to the infrared. Okay. And then alpha 6 would be for the oxygenated. Okay, bakit walang C5 tsaka C6? So yung concentration ng hemoglobin tsaka concentration ng oxygenated hemoglobin, same lang syempre. Kasi same blood naman siya. So C2 pa rin. So wala tong kinalaman kung hindi siya magbabago kung nagbago yung incident light. Okay, si alpha magbabago. Okay, kasi sabi ko nga quantum mechanics. May prefer na ilaw yung mga bagay-bagay natin. Pero yung concentration, yung amount ng mga oxygenated tsaka non-oxygenated or deoxygenated hemoglobin would not change, of course. Okay? So that's that. Now, meron kang IR max, IR min. Tapos may IR max ka tsaka IR min. Okay, now parang dito. Ano kinalaman nito sa voltages? Ano kinalaman nito sa circuits ko? Okay, so medyo hindi siya straightforward. But, wait lang. Yung mahanap ng lalapagan ko nito. Okay. So kapag meron kang meron ka circuit, meron kang diode, light emitting. Tapos meron ka rin receiver. So ito yung ginawa natin, pinakita ko sa inyo kahapon. Ito yung circuit na. Ito yung photodiode na receiver kasi ito yung emitter. So may ine-emit to, 'di ba? May ine-emit na light to. Tapos lalagay tayo ng finger. Blue na lang yung finger. Kuwari finger yan. Okay. So yung I naught, yung I naught pala. Yung I naught would be the incoming light here. So I naught. Tapos yung lalabas dito would be yung I. Okay? And consequently, pag meron kang ganitong setup, meron ka rin matatanggap na voltage kapag tinanggal mo yung fingers mo tapos pinaglapit mo yung receiver emitter setup mo. So pag pinaglapit ko dito at this part yung receiver diode ko. Kuwari nandito na siya. No? Yan na siya. Makakakuha ako ng voltage na would correspond doon sa I naught. Okay? So nilapit lang natin siya dito kasi nandito yung basis no I naught. So lalapit ko diyan yung photodiode ko, makakatanggap ako ng certain amount of voltage and that would correspond to I naught. Balik ako dito, babalik ko sa original setup ko yung receiver. Then, mag-measure ulit ako ng voltage na walang daliri. Na may daliri na, so makakuha na ako ng I. Okay? And with that I, magko-correspond yun to some certain voltage. And then, tinitignan lang naman natin dito is yung ratios nila. So we could actually see this as the ratio of voltages. No? Voltages nung merong finger and yung walang finger. Okay? Okay. So, yan. So, corresponding na sila. So, ito, pwede mo na siyang isipin as a ratio of voltages. Siyempre, hindi siya straightforward na I over I naught is just equal to V and V naught. Okay? Hindi ganyan, di ba? So, siyempre, meron kang may coefficient ka na magpapantay sa kanilang dalawa. Okay? But, okay, so, ano na yun? Calibration na thing na yun. Okay, anyway, going back to the things that we have, the equations that we have. Now, we have two equations ng max and min proportions, di ba? Ngayon, ayaw natin nung D2 tsaka D1 kasi hindi tayo mag-measure ng vessels. So, we can actually eliminate those by taking the ratio of these guys. Okay. And mas madali kung kukunin ko yung ratio ng logarithms nila. So, ln I R max okay. So mas madali na kunin ko yung ratio nila para matanggal ko yung mga D2 minus D1 tapos pag nilogarithm ko pa matatanggal na yung mga exponential factors. So yung resulting equation would be alpha 2 C2 plus alpha 3 C3 tapos alpha 5 C2 alpha 6 C3. Okay, bakit naging ganun? Okay. Pag kinuha ko yung logarithm, kinuha ko yung logarithm, ito na lang matitira, yung exponent na lang matitira. So, ln of e raised to negative x is just negative x. Tama? Okay? Okay, and then ginawa natin would actually look like this. ln okay? So, ganito nangyari. Kaya naging positive din. Puro negative signs itong mga to. Negative, 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 negative. Tapos yung mga D2 minus D1, common factors sila. So, magka-cancel. Cancel sila. Tapos ito na lang matitira. Bale, alpha 2, C2 plus alpha 3, C3 divided by alpha 5, C2 plus alpha 6, C3, which is this one. Okay? Okay, let's call this equation R. Okay? And then ano kailangan natin? Actually, parang kailangan mo naligaw na tayo. SPO2 yung kailangan natin, di ba? Ito ay given by concentration ng oxygenated hemoglobin, tapos yung total. So in our equations, yung HbO2 ay actually C3. Yung denominator ko would be C2 plus C3. Okay. And now, it remains na lang na pagsamahin ko itong dalawang to. Okay. Easily, madali itong hiwa-hiwalin. So, pwede mo siyang isulat as ganito. Alpha 2, C2 plus alpha 3, C3 equals R times alpha 5, C2 plus alpha 6, C3. Kita niyo yan, minultiply ko lang yung denominator to both sides. So, lumipat lang siya dito. Okay? Now, I can separate C2 and C3. So, alpha 2, C2 plus alpha 5, C2. Ay, minus pala dapat siya. Kasi nilipat ko na sa left side. So, we have this. And then on the right side, we have R alpha 6, C3 minus alpha 3, C3. Okay, now you can choose whether gamitin mo yung C2 tsaka C3. So C2 na lang gagamitin ko in terms of C3, no? Para isang plug-in lang ako dito. So C2 is actually given by R alpha 6 minus alpha 3 divided by alpha 2 minus R alpha 5 tapos C2 ay C3. Okay, C3. Okay, and then I plug in this guy to our SpO2 equation. So we have C3 over R alpha 6 minus alpha 3, alpha 2 minus R alpha 5, C3 plus C3. Okay? So C3 unbothered, wala akong ginalaw dyan. Yung binago ko lang yung C2. Pinlog-in ko yung yung nakuha kong equation. So we have this and C3 cancels now. So we have 1 over 1 plus R alpha 6 minus alpha 3 divided by alpha 2 minus R alpha 5. Okay, and then pwede mo siyang ayusin para mas cute. Ito ay magiging alpha 2 minus R alpha 5 divided by alpha 2 minus R alpha 5 plus R alpha 6 minus alpha 3. Tama? Tama. So, minultiply ko lang yung denominator nito dito sa 1. May common denominator na sila. No? Kasi yung common denominator nila can be flipped to the numerator. So, ito na siya. Okay, tapos ito na yung denominator. Kuha ba? Nakuha. Multiply dito. So, ito na yun. Denominator na. Tapos may common denominator itong buong to. So, yung form niya is somewhat looking like this. Okay, tapos naging y over x na lang. Okay? Okay. So, ito siya. Okay, double check ko lang. Okay. Multiply tayo ng negative sign both numerator and denominator. I-flip lang natin. Pwede ka mag-multiply ng negative 1 over negative 1, diba? So, walang issue dun. So, I have R alpha 5 minus alpha 2 all over R alpha 5 minus alpha 6 plus alpha 3 minus alpha 2. Okay? So we have this. Now, sabi ko nga, yung ratios nung IR max, IR min could correspond to the voltages that you can measure on your circuit. So this whole thing here, yung R mo, is measurable. Okay? Measurable siya. So ang problem mo na lang would be finding the alphas. Okay? Finding the alphas. Now, syempre, you can always perform experiments. No? Kunyari, employed ka sa isang bonggang corporation. Then may freedom ka to design experiments that could measure the different alphas for your tissues and so on. But in practice, mas madali kasi na gamitin mo na itong i-approximate mo na lang itong mga bagay-bagay na to na depende sa measurement na makukuha mo. Okay? So, paano ba natin gagawin yun? Okay. Now, meron tayong equation na ganito. Ano itsura ng equation natin? Mukha siyang x plus a over x plus b. Hindi, mas maganda na yung mas general form. ax plus b tsaka cx plus d. Okay? So mukhang ganito yung equation mo. This would look like appropriately, no? Kung gawin mo siya sa graphing tools mo. It would actually look like this. Okay, something like this. And this is your y, this is your x. Okay? Tapos, ito ay 1. Okay, bakit ko nasabing 1 to? Kasi ito ay SpO2. So yung numbers mo would range lang from 0 to 1. Okay? 0 to 1. Kasi siya ay percentage. Okay, now. Ito ay mahirap mahirap siya in practice gamitin. Mahirap to gamitin in practice. Kasi mahirap mag-regression pag ganito equation mo. Linear regression, fitting ng numbers. Okay? So ang magandang model dito is you're gonna use a different fitting graph. So you can actually have something that is exponential. Okay? Mas maganda. Yan. Okay. So you can actually fit a quadratic formula here. Okay. So magiging accurate lang siya on some parts of your graph. Syempre kasi nag-fit ka nga lang ng nag-best fit ka nga lang na SpO2 mo. Actually have A R squared plus B R plus C. Syempre hindi mo accurately makukuha yung form nito. Some parts makukuha mo, yes. To some extent. Okay? But in the end, mas madali mag-handle ng regression pag ganito equation. Kasi mas madali yung fitting ng equation pag ganito. Okay? And then, saan point ka saan point ka mag-fit ng saan point ka mag-fit ng highest accuracy mo. Okay? So for the oxygenation ng blood, ang important dito is yung normal range, which is around 95 to 100 ata, I think. 95 to 100. Okay, so mag-fit ka ng measure ka ng mga R, tapos fit mo na measure ka ng R tapos sa mga normal oxygenation ng mga tao. Then you fit those numbers to this quadratic form. Okay? And then bakit yung normal yung basis natin ng measurement? Bakit hindi yung lower than this? Kasi lower than this, hindi na nagma-matter kung gaano hindi na nagma-matter kung gaano kagrabe. Hindi mo kailangan maging accurate kapag nasa 0 ka na or nasa 50 ka na or nasa 60 ka na. Hindi mo need maging accurate at these points, at these oxygenation SpO2 oxygenations. Okay, bakit? Kasi pag nag-drop yung numbers below 95, mag-worry na agad sa yung mga tao. And regardless, okay? Yung mga doktor, bumaba ng 95, 90, 92, 93, mag-worry na sila sa'yo. It doesn't matter kung nasa 60 ka, ang point ay mamamatay ka na pag less than 90. Okay? Mag-worry na sila pag nasa 90 to 95, pag less than 90, you're in danger. Okay? Doesn't matter kung nasan siya. Kung 55 or 90 or 80, something's wrong. So dapat i-check na nila kung ano yung mga nararamdaman mo. Okay? Okay. So in practice, ito yung ginagamit na fitting equation. Okay? Tapos yung mga manufacturer would have syempre yung mga workers nila, mga physicists and engineers nila would determine A, B, and C. So yung numbers ng A, B, and C would be parang yung secret recipe nila for that specific device or specific oximeters. Okay, so mga pinoproduce nila. But then again, and always proceed here, no? Hanapin mo yung mga alpha numbers. Ayan. Okay, so yung process na ginawa natin ngayon would also work for other optical measurements, no, na gumagamit ng intensities. Okay? So anything na material na ano, no, na any material would absorb using this Beer-Lambert's law. Basta alam mo yung path length, yung concentration ng molecules dun sa pinagme-measurean mo, tapos yung absorption coefficient nung hindi po publicly available yung mga alpha coefficients. Hindi ko sure. Try nyo maghanap. Pero kasi ang point ay mahirap hanapin yung alpha ng ano. I don't think so nag-exist yung alpha ng tissues. Kasi halo-halo siya. May dugo, may hangin, may sugar. So halo-halo yung nasa loob ng ano. So makukuha mo siguro alpha ng ano, no? Alpha ng yung individual elements no. Pare sugar, ganyan. Hemoglobin itself, yes. Makukuha mo sila. Pero kasi yung mahirap dito ay may maraming magi-interfere dun sa measurements mo. Okay, maraming material na magi-interfere sa measurements mo. Okay, any questions? Any questions? So marami pa tayong tatalakayin na other biomedical signals. Magba-blood flow tayo, temperature, hopefully pressure, ganun bagay. Okay, any questions? Sir, limited po ba sa IR yung pwede na gamitin for the final project or pwede ba gumamit ng iba pang diodes? Pwede naman kayo gumamit ng iba pang diodes. Sige lang. Ang provided ko lang ay yung infrared. Okay. Yun lang provided ko. Pero kung gusto niyo gumamit ng iba pang other means of measurement, okay lang. Go lang. Okay? Infrared lang yung binigay ko kasi yung malapit nasa infrared yung nire-reflect ng nire-reflect ng glucose. Okay, so pwede pa kayong gumamit ng iba. Paano po ulit na ma-measure yung R? Sige. Yung R measurement mo would be bubuksan mo yung red light mo. Kunin mo yung walang nakalagay na finger, tapos yung nakalagay na yung finger. Okay, tapos hindi. Pwede mo gawin yun, tapos makakancel mo yung makukuha mo yung IR max and IR min sa pag-heartbeat nung signal mo. Okay? So ito ay gumagamit ng heartbeat. So yung ratios nung mataas na voltage divided by dun sa mahinang voltage sa heartbeat. Or kung dito gagamitin mo, kung dito ka gagamit, kung rekta dito. Dito naman, ito yung tawag dito. Yung walang finger tapos yung may finger. Okay? Minsan kasi kunyari sa other optical measurement systems, walang heartbeat or hindi magmamatter yung heartbeat. So mas stuck ka dito. So magmamatter yung matter yung sa alpha nung sa tissues and everything else. But for this case, oxygenation, kunin mo lang yung yung peak ng heartbeat tapos yung trough ng heartbeat. Tapos patayin mo yung red light, buksan mo infrared ngayon. In the same way, makakuha ka ng max and min. May number ka na. May number ka na for the ratios. Yung numbers na yon, ilo-logarithm mo. Okay? Then you get the ratios of that logarithm numbers. Okay? So ayun yung R mo. Okay? So after nung nakakabit pa to sa sa Arduino or whatever na magka-calculate na itong mga bagay sa iyo. Syempre hindi mo na ipapa-calculate sa device mo to. Okay? So sa computer na sa computer na or yung Arduino na magka-calculate ng mga bagay nito. Okay, may tanong pa. So yung exam 3 po ba after ng final project sa December 14? Yes. So December 17. Paano pa malalaman yung proportion constant ng intensity tsaka voltage output? That depends kung kailangan mo siya. That depends kung kailangan mo siya. For the heartbeat, hindi mo siya kailangan, di ba? Kasi yung ratios, okay na siya. Pero kung dito ka, by experiment siya nakukuha. May masasuggest po ba kayo na references na pwede namin gawing guide? Marami sa online. Search lang kayo. Tawag dito. Non-invasive blood sugar monitor. Mga ganun. May mga papers dyan. Hindi nyo ma-miss out. Okay. Any more questions? Okay. Kung wala na or kung meron man, email nyo na lang or message me. Okay? Okay. So sige, gamitin nyo na yung oras para mag-aral kayo. Ako yung nag-worry para sa inyo. Mahirap yung exam. Feel ko hindi ako makakapasa doon sa exam dahil mahina ako sa 151.